Welcome guys, welcome to my channel. There is a question of data structure first day. Now this question number one. Suppose we have Q this for 40, 110 and 25 and 200 and an empty stack. We are allowed to perform only two actions. These are actions if we DQ an element from Q and push it on to stack S, and action Q. Pop an element from the stack, yes, and enqueue it into queue. Which of the following sequence sort the queue in ascending order? Then तो पहले मैं क्यू इस क्यू में 40, 110 एंड 25, 200 एलिमेंट है. देन स्टैक है एक जो मेरे पास एम्प्टी है. तो मैं इसको असेंडिंग ऑर्डर में सॉर्टिंग के लिए इसको पहले 40 को मैं पॉप करता हूँ यहाँ से. 40 को मैं पॉप करता हूँ एंड देन पुट इन स्टैक and then put in stack 40 and after that 110 also pop from the and dq from the queue and then put in stack. There is p operation and then 25 mm, then 110 and pop out from the stack and put in q 110 and then after p means dq an element from q and push into the stack and 25 again and dq from the q and put in stack for action q from q operation and then p again 25 pop from the stack and put in um, q. And then after q operation again um, 40 pop out and then put in q and and then 110 pop out from 200 and dq from the queue and put in stack and 110 also pop out dq from the queue and put in stack and then queue operation we pop out from the stack and put in dq and then 200. This therefore it is sorted in our ascending order. There is my mistake some. This is also good. This is also good. So in this way first question I will solve and now second. And now second, consider the following sequence of keys used to construct binary search tree: 1847, 1954, 53, 63 and 60. For how many choices of root element? Total number of binary search tree means it asks how much binary trees can be formed, so that how much root it means 70 बाइनरी सर्च ट्री बनानी है हमें, जिसमें कि मैं हाउ मैनी चॉइसेस मेरे पास कितने चॉइसेस है कि मैं रूट एलिमेंट कितना ले सकता हूँ जिससे मेरा 17 बाइनरी सर्च ट्री बने. तो देयरफॉर आई सॉल्व by this method catalog number for generating binary search tree of from given n number of nodes. If if we use n means one number of node, then catalog number one. If n बराबर 2 nodes, then we create two binary search tree. If n बराबर 3 nodes, then we create 5 number of binary search tree. So that if we want 17 binary search tree, then we multiply generating these. We if we want 17, then we 14 multiply by 5. 14 5 just 70. It means if we put n is equal to 3 left side and n is equal to 4 right side, then we create 17 binary search tree, because 3 if 3 node here left side, then we create 5 binary search tree, and if we put 4 element either then right side, then it will create 14 left right subtree. Then it multiply, then it form 45 to 70. If we also can make these trees with 44 element left side and 3 element in right side, we also create binary search tree. In this way we create, if we take 90 in binary search tree, we know that in left side all sorted element, if we sort this array, this will form, if we sort this array, then 19 will be in fourth position in the array, and then 4 7 18 18 in left side, and then these are the right side. If we put 53, if you take 53, then these are in right side and these are in left side. That's why I solved this question. Now, third question. Consider the operator precedence and associativity of these. In this, plus operator have highest precedence and associative its left, and minus operator has high precedence, associativity right, and operator multiply have medium precedence and divide as low precedence. Then I solve this in this way. Plus has highest precedence. Then I first solve these 3 plus 1 plus 5. And then it will form 9, and 7 plus 2 it will form 9. Then after I will take minus operator. In this we put its calculation 9 9 its calculation 7 plus 2 9 minus 4 minus 7 minus 6, then it will create 6, and then we take multiplies its precedence is median, then 9 into 2, 9 to the 18, and then divide, and then divide precedence. In this we take associative right associative, so we solve from right side, then these two, then we solve this, divide 2 3 are 6 and 3 6 are 18. Therefore answer is 6. In this way I solve this question. And this and then next question is the result evaluating postfix expression. I solve using the stacks 10. First we push these number 10 and 5 in stacks, 10 and 5 and then operator is this plus, then we take these two operations and perform the operation 10 plus 5 15, and then 15 is pushed in stack, and then 16 and 6, and then again operator is find, then we perform the operation 16 take 2 operate 60 plus 6, then divide 6 by 60, then we find 10, and then again it put in stack, and then multiply operator I found, then multiply operation is performed, 15 is left in the stack, then we pop these 15 and perform the operation, 10 plus 15 into 150. Now minus 8 and minus, then we perform these last operation, I will get 142. In this way I solve this question. Correct answer is C. consider these are the expression how following sequence list of triple representing the given expression with entries missing triple. So in this first we solve p plus r and then second is solve addressing mode. I solved in this way. First p plus r and then it solve addressing of array si. In this si, first calculate yes array index with I index plus. Then in this first operation, it will put the yes from the I index. It calculate the array element. It calculate the yes array element from the I index. And then we will put at first this, and then second minus 1 si. It will convert the si calculated address in minus second, and in third we will multiply these 2 and this plus operation 0. Then 0 into 2, so then 0 into 2 are here, 0 into 2 and 0 into 2. So these are first one is correct because array is calculated, and these are multiply operation performed at third position in the three address code. And then 6 we will put the value in the array, therefore 6 x array with index I is calculated in 6, therefore option A is correct. I solved this way. Now, sir, next question is let S1 and S2 be two stacks in which four element in S1 and S2 already S S1 already have four element where S2 is empty. Then these are the operations which are performed on these stacks. I will solve these in this way. First, we will take stack 1. I found that these order is found because I only perform these operations. Pop the top element from S1 and push it on S2. Only S1 pop the element from S1 and push in S2, and in push to S1 may pop the top element from the S2 and push in S1. So I will perform and generate output only. We pop the element from S1 and output it display. So in these are the S1 and S2 is initially empty. I will generate this sequence, but these sequence are not generated by this operation. We calculate this like 300 if we 400 pop from S1 and put in S2, and 300 is um, generate output, and then 200 is generated output, and then from here pop from S2 and pop and push in S1, and then pop again from S1, and then S1 this sequence is generated, and then this sequence is also generated because from 400 is pop 1 and 300 is push in S2 and 200 is pass 1 pop 1, and then 100 is pop 1, then 300 is push into S1 and then pop 1. This second one, third one is also generated, and fourth one 200, 400 and 300 we push in this stack, and then 200 is pop from S1, and then 300 is pop from S2 and then put in S1 and then again pop from S1. 300 is also, and 400 is also from this and this, from here to here. And 100, it is also from pop from S1. In this way I solve this question, but option A is not generated, so it asks which of the above output sequence can be generated by the above operation. I will generate B, C, D, but A is not generated. Now, next question is, consider a sequence of element A0, A1, and A2, and A3, and A4. These are the numbers, and the following operations are performed on these stacks and queue, both of which are initially empty. Initially these are empty. I will solve in this way. First we take the all variable and put in it. Said that push the all element of from A to A5 in that order into S. Then I will put this in stacks in this order: A1, then A5, then A7, then A8, and then A9 and A2. In this order I will push this number in stack, and then NQ element from in this are in queue. This is this are queue in same way. NQ the all elements in the queue. Then I will NQ these element 1, then 5, then 7, then 8, then 9, then 2. Now it said pop an element from yes. Pop an element, I pop the element 2. No, this here from here. 2 is pop, and then DQ an element from Q. DQ an element from Q, and then DQ from here, and then pop an element from S. 7 out. No, 8, 2 out, 9 out. 9 out, and then DQ an element from Q. 5 is DQ, and then DQ an element from Q and push the same. From here I will 7 DQ and push this in stack 7, and then repeat the operation 7 3 times. Then I will DQ 8 9 2 and put them 8 9 2, and then pop an element from yes, pop an element from yes 2, and pop an element from yes 9 also pop. The top element of yes after execution is 8. 8 is the answer. In this way I solve this question. Next question is, a queue is implementing using a non-circular single list. The queue has a head pointer and a tail pointer as shown in the figure. Let An denote the number of nodes in the queue. Let Nq be implemented by inserting a new node at the head, and DQ be implemented by deletion of node. There are two operations, NQ and DQ. NQ means insert the element from the head, and DQ means deletion of the node from the tail. Which of the following time complexity? If we insert the element from head, it will take one time complexity, because we put the next pointer of the our new node to um, implement the head, and then head will um, um, and then new node pointer to put the address of new node pointer into head. If we delete the node, then we will need the before its node address of before it node, so that point the tail pointer to that node, but its address is required me. तभी तभी तुम्हें प्रीवियस पॉइंटर का एड्रेस टेल को पॉइंट कर पाऊंगा. सो So we will mm, take n time complexity for traveling to previous node from here to here then here to find this address of previous one for pointing the tail to previous node. If we delete this, so it will take on times. So option B is correct. In this way I solved this question. And then the next one is the pre-order traversal sequence of a binary search tree is this pre-order traversal. From given pre-order traversal I created the binary search tree this, and it asked which one is post-order traversal of the same tree. Then I will solve the first we create the binary search tree from pre-order and then post-order is created. Post-order is basically leaf uh, from right node. Right node it follow the rule like left, right, then no, then node. First left child, then right child, then after that node. In this way, post order I calculated like right child of 10 is 15, then 10, then 23, then 25, then 20, then 35, then 42, then node 39, and then the root node 30. In this way, I solved this question. Now, consider a binary heap, mean heap containing 105 distinct elements. Let key be the index in the underlying array of the maximum element stored in the heap. The number of possible values of keys it asks about maximum element in the mean heap. So we know that in mean heap maximum element always stored in leaf node. If we if we 105 distinct element, then 105 distinct element, so we divide 105 with 2 to find the leaf node in a because 105 element to find the leaf node uh, we know that if we divide the total length of array with 2 we will find all leaf nodes. To finding all leaf node we will divide by 2. 105 divided by 2 and we'll take um, upper bound, then we will find the first leaf node, initial leaf node. Therefore for 53 is it is possible it is leaf node in these 105 distinct element. So, so a correct option is 53. Now let A be the priority queue for maintaining a set of elements. Suppose A is implemented using a max heap data storage. The operation extracts and delete the maximum element from A. The operation insert a new element key in A. The operation of max heaps are preserved at the end. In the worst case runtime complexity, it asks for max element extraction and deletion of the max element and insert a element. If we extract the max element from the priority queue, then it also follow the property of the priority queue after extraction or deletion. Then if we extract max element from the priority queue, then its position is placed by last leaf node. Then we apply hippie pi operation. Then it takes O log n times. Stack max operation is takes O log n times. And then insert operation, it is also takes O log n time because I will put the last I will put the insert node new node in leaf, and then hippify operation is performed. In priority queue O log n, this operation is performed. Correct answer is B. Now meld operation on two instances of data structure combines them into a single instances of the same data structure. Consider the following data structure: unsorted doubly linked list with pointer to the head node and tail node of the list. These are the doubly linked list unsorted. Mean heap implemented using an array. Binary search tree, which one of the following operation? Basically, question asked if we two binary search tree structure we combine them, then it will also follow the binary search property, mean heap property, and doubly linked list property. Then it in worst case, how in worst case what is its complexity of n size data structure. If we add to unsorted doubly linked list, then it takes O1 time complexity because next pointer it point the next head node of the next data structure, and then its tell it is also point the previous tells of previous data structure. Then it takes O1 time complexity, and mean heap implemented using an array, it takes O(n) time complexity because these are array. If we add these, take O(n) time to add the second array into the previous one, and for hippify it takes O(n) times. Therefore total it takes O(n) times. And binary search tree, it will also take, because binary search tree it is also n size of data it contains, and if for preserving the binary search tree property it takes log n time, then it total time O(n) time. Therefore correct option is 1 A. Now next one is, this is C function foo and binary tree shown. These are the binary tree and these are the function. What will be the print? It will print may be typed at stroke node star left star right node. If node is equal to null, then it will return 0. If not null, then it will go on left first, then right. Then it will go left, left, then it will return null. If it null, then return it 0. If it is not, if it is 3, then it will full up null 0, and these are 0 for this value, and p value is 3, then red value is 3, then it return 3. First is print 3, first is print 3 3 3, and then it goes for right, for its left, and then it go for right, this right operation. Then here it will print 8, पहले 3, then 8, then 5, because it first go left and then right and then the root value. Then it will print 3 8 5, 3 8 5, 3 8 5. This one is correct. Correct answer is A. In this way I solve these questions. And now next one is Consider the array representation of binary miniv containing 1023 elements. The minimum number of comparison required to find the maximum in the heap. You know that min heap contains maximum element in the leaf. In 1023 element, it will divide by 2. I will find the leaf. If we take upper bound, I will find the leaf element. Leaf element, there is leaf element upon dividing 1023, 1000, 1023 is divided by 2. Then I will find approximate equal to 5, 5 point 5. Then I will approximately equal to 5, 1, 1 comparison. 511 comparison maximum. Okay, the next one is the next one is this 5-1 comparison, and consider the following algorithm. Some algo that takes let V be the and vertex in G, run BFS on G starting at V, let U be the vertex in G at maximum distance from V as given by BFS, run BFS on G again with U as the starting vertex, let Z output the distance between U and Z. It basically says that let any vertex in on G, let take this is a V, and from here I will run the BFS algorithm, and which one is longest distance, maximum distance, I will take these those vertex which one is maximum distance from here. Then I will find that this is the maximum distance, this is the V vertex. Now from here U vertex, from here I will again apply BFS algorithm to find maximum distance. Then I will go for Z, then I will find these are the maximum distance and these are the maximum distance. So from here to here, how many is 1 2 3 4 5 6 6. So the distance between these, maximum distance between these 6, so answer is 6. It is asked for the distance between U and Z. U here and Z is here, then the maximum distance between this 6. In that way I solve this question. Now next one is let G be any undirected vertex unweighted graph with 100 vertex. Let DUV denote the number of edge in the shortest path between vertices. Let maximum value of DUV such that U not equal to V be 30. Let T be any breadth first search of G, which one of the given option is correct for every such graph. Let first understand it will gives maximum distance between the vertex is 30. It given, it means It means if we apply breadth first of any vertex of the tree of a given graph G, then it will give maximum distance 30, but mm, but it was for height, but it asked for height. Maximum distance may be 30, then it will from this binary tree is like a tree, like this binary tree, this binary tree, this and this and this. Uh, from here to here, these are the maximum distance, but it asks for height. Therefore, for height, it will exactly 15. Not it exactly 15. If we from here to here, then it will contains 30. If there is 5 and there is 25, then its height will be 25. If you say that the height is at least 15, it is maybe correct. It is maybe correct because at least means 15 will be definitely, or greater than, it is correct, but less than 50 it is not possible because it is say that maximum value is 30. Maximum value means matlab distance between two node is 30 maximum. Therefore if we apply anywhere BFS of the node from in this tree node, it will find at least 15 height will be possible. At least 15 is definitely possible, but exactly 30, exactly 50 it is not possible, and the height of T is at least 30, it is also not possible. So option C is correct. Now next one is in double hazing schemes. First hazing is k mod 11 and second one is 1 plus k mod 7 and are the auxiliary function, and the size m of the hash function table is 11. Size of the hash function I created first, and then these are the key we want to put. Then 63k modulo first hash function we applied. If collision occurred, then second function is applied. Then this function is applied. G first prop 0. If not collision occurred, we will put prop is equal to 0. Then we will find 8 mod, therefore put here, and then 6 mod, then we will put here, and then 3 mod I will find, then put here, mod 2, then I will put here, and then 1 I will put here, and then 2, there is collision occurred, so therefore prop for next I go prop 1. Then here I find the again collision. Again 6 has collision. So I will go for prop 2. Then here I found mm, 10 by performing these operations. I is equal to 2 and H2 has in applied and H1 has in applied. Then I will find these. Then 10 at 10 place is it not occupied, then we will put 24 here. In this way I solve this question. Now next one is consider a hash table with 100 slots. Collision are resolved using chaining. Assume simple uniform hashing. What is the probability that the first three slots are unfilled after the first three insertion? It basically asks for first three slot is empty and first three slot is empty probability, it will basically ask. So total possibility to 100 into 100 into 100, 100 power of 3 total possibility. Now for possibility of first three slots is empty, then first months first first key are not put in first three slots. So for key first possibility are 97 not put in first three slot. So possibility are like I will draw this. I will draw this. Oh shit. This and this and this and this and this and these are the 97 and these are the 97 and first first key are not put in first three places, so there is 97 possibility. Second key is also not put in these places, there is no 97 possibilities. And third key is it is not placed here, then it is also have 97 possibilities. Someone thought 99, 98, 97. If we take 99, it means there is the possibility. So it will say that not first three slot used. So we will take 97, 97 and 97. So option A is correct. In this way I solve this question. Now next one is next one is which of the following is essential for converting an infix expression to the postfix form efficiently? We know that stack is used for infix to postfix conversion, and for this, an operator stacks are used for infix expression to postfix expression efficiently. Now, next one is consider the following first in, first out types of computation are efficiently supported by stacks. First in, first out. No, this is not. Implementing list on linked list is more efficient than implementing list on an array for almost all the basic list operation. Yes, linked list is more efficient. These are the correct. And next one is implementing queue on a circular queue is more efficient than implementing queues on a linear array queue. Yes, circular queues are more efficient than linear queue. Last in first out type of computation are are efficiently supported by queues. These are wrong because last in first out is performed in stacks, not in queues. So option A is correct. Option A is correct. No, the base data is just structure to check whether an arithmetic expression has balanced parentheses. Base data structure stack. Option B is correct. Now consider the following sequence of operation on an empty stack. Push this operation. In this way I solve this question. First we take stacks, empty stack, and then push 54, 52, and then pop, and then push 55 and then 62, and then pop 62 is popped in is yes. After then DQ and NQ operation, then 21 NQ, then 24, then 28, then DQ operation, then NQ 28, then 32, and then Q barabar 24. So yes and Q S plus Q is equal to 86. In this way I solved this question. Now that's these are the questions on data structure, and thank you for supporting me. Like and subscribe and comment this channel for later update. Thank you.